right, let's get started on today's lesson, everybody. We're going to be looking at Euclidean geometry. And I know that many of you don't like Euclidean geometry, but we're going to be fine. Trust me, we're going to be perfectly fine. All right, let's start off with this question over here. I'm going to put it on the screen, okay? And we're looking at a rhombus, a question that gives us a rhombus. Now, I want you guys to have a look at the information for 8.1. Okay, just have a look at the info. And once you're done looking at the info, give me a thumbs up if you're confident you can answer this question yourself. Give me a thumbs down if you feel like you're going to need my help. Okay, thumbs up. I'm good to go, ma'am. I've got this. Thumbs down. Ooh, ma'am, what am I doing? Help me. Let me know. How do we feel? Are we going to be able to do this? Hello, Pascal. Okay, Funzo's giving me a thumbs up. Pascal's like, okay, Pascal, do what you can. Tell me what you can do. Okay, do what you can. Anybody else? I just want to gauge where everyone is. I don't want to leave anybody behind. Okay, I want you guys to feel comfortable. Tell me how we feel about doing this question. I feel like I have 3 people in the class today. Most people aren't connected to audio. All right, okay, I've only got 2 thumbs up. So I'm going to assume everybody's doing okay. And I'm going to give it about 5 minutes, and then I'm going to start looking at the answers to this question. All right, so you guys have 5 minutes. Okay. 2 more minutes, guys. Remember to pop your favorite emoji in the chat when you're ready. No worries, Nomatlubi. We're going to look at the answers for this question. All right. Okay. So the question here says that KLMN is a rhombus. Okay. So as soon as we hear that, we need to think of all the properties of a rhombus that we know. Okay. We know that all sides of a rhombus are equal. So I know that this side and that side and that side and that side are all equal, right? I also know that each pair of opposite sides are parallel. So this side is parallel to this side, and this side is parallel to that side. Okay. Now, I also know that the diagonals bisect. Who can remind us, what does it mean when we say that the diagonals bisect? What does that tell us? What does bisect mean exactly? When we say that diagonals bisect, what does that mean? Correct. They mean cut. Good. So what Pascal and Tyreka have said, we're going to take those two things, put them together. Right. They cut. Cut means bisect, but bisect specifically means cuts in two. That means that this side is equal to this side, and this side is equal to this side. Good. It divides into equal parts, but specifically in a rhombus, it also bisects at a particular angle here at the middle. What do we know about the angle here in the middle? What angle do we get where they bisect? This is the part where you guys can do a little bit of cheating and let me know. The diagonals bisect at what angle here in the middle? You can look it up. You can flip through a book quickly. It's not a vertex angle, my sweetie. Angles are made up of vertices, so not quite. There's a particular angle. That's it. Part 2. Hello, part 2. Yes, they bisect at 90 degrees. Good. That's 90. That's also 90. That's also 90. All of them bisect at 90 degrees. All right. So that's the information that we have so far. By the way, if this side over here, if K on this side is 34 degrees, what does that mean that K1 is equal to? What is K1 equal to? It's in the word bisect. I'll tell you that. Because this line KM bisects the angle at K, if this is 43, if this is 34 degrees, What do we know K1 to equal? Not 56 part 2. If it's bisected, that means it's been cut in half. Yes, we've just spoken about this. That means it's cut in half. That means if this side is 34, this side must also be what? Yes, Pascal. Good. This side over here must also be 34. This side is also 34 degrees. Look at what I'm doing now. 34 degrees. All right, let's have a look at some of these questions. Yes, that's what bisect means, part 2. Yes, 100%. All right. It says here, 8.1.1 says, write down the size of angle O1. Lucky for you guys, I've just given you O1. It's 90 degrees. You're welcome. O1 is equal to 90 degrees because the diagonals bisect at a 90-degree angle. Right. Now it says, calculate the size of L1. What did we get for L1, everyone? Let me know in the chat. I'll tell you something. I can use the triangle KOL to get the answer I want. What is the angle for L1? Correct, part 2. That's it. Good. This angle over here, L1, is equal to 56 degrees. Good. And Pascal, remember the most important thing, that we must also give a reason. This is Euclidean geometry, guys. In fact, in all geometry, we normally have to give reasons, except for analytical, which is kind of nice. Right. So we know that that is equal to 56 because of angles, sum in triangle. However you say it, angles in a triangle, interior angles of a triangle, it's fine, as long as they are inside. Ah, Pascal, it's not that bad, especially when you know what you're doing. All right, now the next question says, calculate the size of KNM. Now, let's go look for KNM quickly. Okay, if I look for KNM, K starts there, KNM. I'm looking for this whole side over here, that whole angle over there. All right, now there are a couple of things I know. I know that L1 is 56 degrees. One of these angles, okay, and then I can also say that N2 is equal to 56 degrees. Correct, Pascal? That's it. I can say N2 is equal to 56 degrees because of alternate angles. Good. Alt angles. And I also need to name my parallel lines. I have to say that KL is parallel to NM. Good. But just like what we said, part 2, if N2 is equal to 56, N1 is also equal to what? N1 is equal to how much? Good. It's also equal to 56 degrees. Lovely. Because the diagonals of a rhombus bisect. Diagonals of rhombus bisect. They bisect the angles. Good. Therefore, I can then say that angle KNM is equal to 112 degrees. All right. Give me a thumbs up if we're all okay with how to answer these questions. Are we all okay with how ma'am got to the answers of these questions? Are we all right? Excellent. Beautiful stuff. Beautiful stuff. All right. Here's your next challenge. And I'm just going to erase this tiny part here at the end. Okay. 8.2, it says here, we're given the parallelogram PQRS with diagonals PR and QS intersecting at M. Right. Now it says, prove that the diagonals bisect each other. Now, I know that I have to prove that the diagonals bisect. Can I just say that the diagonals bisect because properties of a parallelogram? Can I do that here? Can I say that? No, of course not. I can't say that. Okay, because that's the thing that they're asking me to prove. So I can't do that. But don't stress, Pascal. It's not even that deep. But I know that my parallelogram is made up of what? What is my parallelogram made up of? Of other kinds of shapes. What other shape? What other shape is it made up of? Good. Yes, that's it. Good. It's made up of triangles. And what do we know about these triangles specifically? They're going to be what? They are going to be? Yes, part 2. Beautiful. They're going to be congruent. So we're just going to have to be very careful about which triangles we choose. Now, remember, guys, if we want to prove that our diagonals bisect each other, we need to prove that the one line cuts the other line in half, right? So we can do this. We can either prove that QM is equal to MS, or we can prove that PM is equal to MR. Either one of those, right? So what are my two triangles? Which two triangles am I going to be working in? Look at what we've got, guys. Let's map them out. Okay, give me two triangles that we can work in. Okay, I'll tell you something. Both those triangles must have M in them. Anybody got any idea? All right. Okay, let's start this proof properly. Let's start properly. Let's not just start halfway. Good. MPS. Good. We can do MPS and SMR. Okay. Part 2, that's not going to help. Okay. If we do PMS, we're going to go PMS. You see how I've used the long side. If I do SMR, if I go SMR, I'm now using the short side. And that's not going to help me, but part 2, there we go. MQR is correct. Oh, QRM. Now, remember, guys, we did say that when we map out these triangles, they need to be in the correct order. So let's start our proof properly. All right, we're going to start by saying RTP. Who knows what RTP stands for? Someone in the other class said rest in peace. I don't think that's what it's supposed to stand for. What does RTP stand for? Who knows? You're going to need it, guys. It's part of matric as well. Who knows what RTP stands for? Anybody? Somebody? Rip, tear, and pray. Rest to power, guys. Focus. Rip, tear, and pray. Really? RIP, tear, and pray. No. All right. It stands for required to prove. Yes, correct, Funzo. Required to prove. Not your friends here just coming up with brand new names for mathematics. We are required to prove. Okay, and we can choose which of these we want to prove. Somebody pick for us. Do we want to prove that PM is equal to MR, or do we want to prove that QM is equal to MS? Pick one. It doesn't matter which one. Somebody pick one of those for us. Whoever puts their suggestion in the chat first, that's the one we're going to take. Thank you, Funzo. We now want to prove that QM is equal to MS. Thank you, Funzo. All right, so we're then going to start proof. Right. We're going to say in triangle. Now, remember we said we're going to use the triangles QMS, right? Oh, sorry, PMS. So I start over there, P, and I go down past PM, up past MS, and then around the long way. So if I start by saying in triangle PMS, I now need to say and triangle. Where must my other triangle start? Where must my bottom triangle start? That's it, part 2. Beautiful. I must start at R, go through the 2 lines to M, past the 1 line to Q, and then back around. So R, M, Q. Beautiful stuff, part 2. Well done. And triangle RMQ. Beautifully done. Now, to prove congruence, I need 3 reasons. 1, 2, 3. Give me reasons, guys. Let's go. Tell me what you know. What do we see in those 2 triangles there? Good. That's it, part 2. Beautiful. Not M1 and M2. Almost. M2 is equal to what? M2 is equal to, that's it, M4. Good. M2 is equal to M4, and your reasoning is 100% on point. Vertically opposite angles. Beautiful. That's an angle. Good. That's an angle. Good. And then Funzo says P1 is equal to R1. Agreed. P1 is equal to R1 because of alternate angles. Good. All good. I agree. Let's see where we got those alternate angles. PS must be parallel to QR. PS is parallel to QR. Now, we need to be very careful, guys. We've got 2 angles. And if we're proving congruence, I cannot use 3 angles. So what Patu is saying is on point. I can't use 3 angles. I need a side now. I need a side. And Patu is spot on. PS is equal to QR because of opposite sides of a parallelogram are equal. Good. Are equal. That's a side. There we go. We've proven congruence. Good. Therefore, triangle PM. No. Pascal, we can't use PM and MR. Okay, because that's also part of the thing that we're trying to prove. It's also another diagonal. I mean, another diagonal that it bisects. So we can't use that. Okay, triangle PMS is congruent to triangle RMQ. And our reason here is going to be angle, side. Well done. All right. Now that we've proven that, automatically, what happens to all the sides of my triangles? My sides are therefore equal. Then I can say, therefore, QM is equal to MS. I can now say that because of congruent triangles. All right. And there is your 4 marks there. Give me a thumbs up. Are we all okay with this question? Are we all good? It was easy. It wasn't like difficult. Funzo, it's not a lot of work. Unfortunately for you, congruence is a grade 9 concept. So they're not going to give you many marks for things that you should have known how to do in grade 9. Sorry for you. Sorry, Dololo. Okay, here's your next challenge. Have a look at it. Okay, 8.3. There it is. Take your time. I'm going to give everybody 5 minutes to try and solve for this one. Okay, take it away, guys. No, Makubi. Funzo, it's not that deep. It is not that deep. Start by reading up here. Start by reading here. Read this. It will explain all. Funny enough, the question we just did above helps this one. It informs this one. Okay. The one above informs this one. Okay. I'll give everybody 5 minutes. Calm down, guys. It's not that deep, I promise. All right, guys, Teacher Nels is 100% correct. Don't overthink it. It's not that deep, I promise. I think maybe we should introduce them to our motto, because I'm seeing people sacrificing 3 marks. Pascal, where are you going sacrificing these 3 marks? Yeah, free marks, free. Okay, so here's the thing, guys. In most questions that we do, even if we don't know where the question is going, we should at least understand that there's a beginning to a question. All right, so our motto is never to close the paper and say, sir, I'm finished, can I go? No, that's not what we do. Our motto is, I don't know everything. I know, I don't know everything, but I know something. Okay. But I know something. We are not starting from scratch because we know what a parallelogram, yeah, to an extent, Pascal, yes. Okay, we know properties of a parallelogram. We know properties of a parallelogram. It's not like we are just here, just in here for vibes, just looking at this question like, yo, the end of the world. No, let's read the information they've given us. Okay, it says here, in the diagram, ABCD is a parallelogram, and we know the properties of a parallelogram, but specifically, they are highlighting the diagonals. The diagonals intersect at E. No, Mashumi, I don't know about just writing anything, but the diagonal intersect at E. Let's start with this statement. DE is equal to what? What is DE equal to? Good, Pascal, good. EB, we're off to a great start. You don't know nothing. You know something. Good. Next part says, the diagonals of parallelogram DECF intersect at G. So there's my next parallelogram, DECF. They intersect at G. So that also tells me that DG is equal to what? To GC. Thank you. Okay, we don't know nothing. All right, let's look at the last one. Then they say the diagonals of parallelogram FGCH intersect at K. So that tells me that KF is equal to what? Good. KF is equal to KC. I'm going to use one line. Good, is equal to KC. Now, let's start with what they've told us to prove. Let's start with what they've told us to prove. All right. They say that we must prove that DB is equal to 4KC. So let's go from KC, work our way up. Right. So my first statement is going to be that KC is equal to KF, right? You've just stated that. All of you have told me that KC is equal to KF. But I also know that KC plus KF is equal to what? What is KC plus KF equal to? Good, it's equal to FC. Now, if I look at the properties of my parallelogram, what other side is also equal to FC? What's the other side that's equal to FC? Correct, part 2. Excellent. DE. Not DB, DE. Be very careful, Pascal. DE. There's FC. FC is equal to DE. Okay. You with me? Okay, good. Now, do we all agree? Just give me a yes in the chat if you agree with me that I can replace KF over here with KC. because they're equal to each other. Can I replace KF with KC? Yes? You guys got me? And then I'm going to replace FC with DE. I'm going to replace them. So now I've got KC plus KC is equal to DE. Add this up for me. What is KC plus KC? KC plus KC? Good. It's 2KC. That's it. That's it, Pascal. KC plus KC is 2KC. Good. So 2KC is equal to DE. Beautiful. However, we also said that DE is equal to what? DE is equal to? Aha, good. DE is equal to EB. Beautiful. I also know, though, that DE plus EB is equal to what? DB, good, is equal to DB, right? Are we all in agreement? Yes or no? I can take EB and I can replace it with DE. Are we all okay with that? Yes? Can we do that? Good. So now I've got DE plus DE is equal to DB. However, we said that DE is equal to 2KC. Right. So I can then say 2KC plus another 2KC is equal to DB. And that is going to exactly 100%, Pascal. That's going to give us 4KC is equal to DB. But was that difficult? Was that as difficult as we thought it was going to be? Nah, don't even lie, guys. This was calm. This was actually very calm. It's very nice. What a nice question. I liked it. I thought it had a little bit. Yes, correct. Yes, Pascal, you're busy here judging books by their cover. Yeah. True, true. All right. I thought this was a really nice question. I think I want to set something like this for my grade 10s one of these days. They must also feel it. Okay. All right. Let's move on to the next question. All right. This next question is from a particular section. What do we call this section? What do we know this as? What section is this, guys? It's still Euclidean geometry, but a specific type of Euclid. Who knows? It's not analytical, it's Euclidean geometry. I'm sorry, Pascal. I'm sorry. But it's like, yo, huh? It's not proving. All right, I'll put you out of your misery. Okay, this is the midpoint theorem. It's midpoint theorem. This is like, yes, midpoint theorem. Okay. Okay, let's start having a look at the question. Okay, question 7.1 reminds us of what the theorem says. It says, the line drawn from the midpoint of one side of a triangle parallel to the second side does what? What does it do? If it's parallel to the second side, what's going to happen to the other side? It will what? Okay, I'm suspecting most of us don't know this, but it bisects. Well, we know how it looks when we see it, but we don't know what it does. It bisects the third side. Okay, and that word bisect has come up so often. Bisects is everywhere. Bisect just means cuts in half. We know this for a fact. Okay. I'm sorry, guys. I'm sorry that all the maths has just like phew, out of your brains. Askis. At least, Pascal, at least you guessed right. Okay. All right, let's have a look at 7.2. Right, it says here, ACS is a triangle. P is a point on AS, and R is a point on AC, such that PSRQ is a parallelogram. Wonderful. So we know that PSRQ is a parallelogram. What does this automatically tell us? Ideas, guys. We know that it's a parallelogram. Tell me what we know. What do we know? Not at 90. That's only in a rhombus, Pascal. Good. PQ is equal to QR. Beautiful. That's it. Not PQ. Not PQ. I always say good. Yes. Thank you. PS. I always say good before I read the whole sentence. Yes. Remember, it's a parallelogram, Pascal. So PS must be equal to QR. Okay. What else? What else do we know? Good. QP is parallel to RS. Thank you, Patu. Yes, that's correct. Is parallel to RS. Yes, Funzo. They do tell us that P is the midpoint. Okay. Actually, no, they don't. They don't tell us. No. No, they don't, Funzo. They do not. They tell us that B is a midpoint. They tell us that, yes, it's not given. So unfortunately, we can't make that assumption. Okay. We cannot make that assumption. All right, let's keep reading the information that we have. CR is equal to PS. Beautiful. That is a given, Nomatlubi. They've told us CR is equal to PS, which is great. AC, okay, PQ intersects AC at B such that B is the midpoint of AR. So we know that RB will be equal to what other side? RB is equal to AB. That's it. Part 2, good. RB is equal to AB. Then they tell us that C1 is equal to 50 degrees. So I know that C1 over here is equal to 50 degrees. Give me another angle that's also equal to 50 degrees, guys. That's it. Yes, Q1. Beautiful. 50 degrees. Okay. Okay, excellent. Let's get started. Pascal says S2. I'm not sure about that per se. We'll have to see. I don't see it. I don't see it. Unfortunately, I don't see it, Pascal, but we'll see. Maybe as we go. That's okay, Kensani. Welcome. That's okay, my sweetie. I understand. South Africa is what it is. All right. Okay, then they tell us that the length of BP is 60 millimeters. So the distance from there to there, 60 millimeters. What does that tell me about the length of RS? What is the length of RS? No. Midpoint, guys, midpoint. The other way around, part two, that's it. The other way around, Funzo, that's it, part two. That means that RS is equal to 120 millimeters. Okay, midpoint theorem, guys. Midpoint theorem. All right. Okay, let's get to the first question. The first question says, calculate the size of A. And I want you guys to note that here, A is worth 5 marks. So there's work to be done. There is work to be done. Okay, where would we start? We need to connect all of this information we have. And remember, A is an angle. So maybe let's start where they've given us angles so we can figure out what's going on. Okay, so if we take what they've given us over here, what other angles can we say are equal to each other? No, Mahlubi, that's not a given. We don't know that. We don't know that. Good, Pascal. Angle R is equal to 80 degrees. Beautiful. We can say that R is equal to 80 degrees. And we still need to give a reason. That's the interior angles of a triangle. Angle sum in triangle. What else? Good. Q3 is equal to 100 degrees. Beautiful, Patu. What's our reason there? Q3 is equal to 100 degrees. What is our reason? We always need a reason. It's geometry, guys. Good. Angles on a straight line. Adjacent angles on a straight line. Okay. Nomachubi says R2 is equal to 80 degrees vert op angles. Excellent. We can also do that. R2 is equal to 80 degrees vert op angles. Good. Let me put that one in as well. So we know that this one is 80 degrees. This one here is 100 degrees. And this one here is 80 degrees. We are almost there. Pascal, if you say Q2 is equal to 50, tell me why. Because nowhere does it tell us that RQ bisects. Patu, it does not make a perfect X though. Oh, you're right. It doesn't. It doesn't. Oh, okay. Yes, you're correct. Yes, we can't say that R2 is equal to 80 degrees because we would need two lines that intersect completely. And we don't have that over here. So unfortunately, we cannot say that R2 is equal to 80 degrees. Thank you for that, Patu. Thank you. Okay, I was testing you. You passed. Okay. Oh, no, actually, it's not going to work with R1 either. Okay. Come on, guys. Where do we go from here? What do we think? Okay, I'll tell you guys, I'll give you guys a hint. It has something to do with the parallel lines. Q3 is equal to A because, yes, you're 100% correct. Q3 is equal to A because of what? Yes, part 2, beautiful. Alt angles, alternate angles, beautiful. And we can say that's because QR is parallel to PS. Well done. QR is parallel to AS. Sorry. Yeah. AS, PS, same thing. AS. I know, Pascal. I know. It's quite hard to kind of see it there, but it is there. It is there. Well done, Patu. Okay, there it is, guys. There it is. All the way there. So that one and that one will be equal. Okay. R3. Thank you, teacher Nels. Why did I call it Q3? Oh, because for some reason in our minds, this whole angle is Q. It's supposed to be R everywhere. Guys, come on now, R3. Okay. All right, and there we go. There's your 5 marks. Come on. Okay, good. Let's have a look at 7.2.2. It says, determine the length of QP. All right. Determine the length of QP. Now remember, QP is from here to there to there. We now know that BP is 60 millimeters, but we then need to figure out what the length of QB is. Yes, Pascal, you're quite correct. Pascal is correct, but you need to tell us why. How did that happen? Not good enough, Patu. We need a little bit more. Good. Opposite sides are equal. Good. Okay. Okay, yes, let's formalize it a little bit. Okay, so I know that BP is equal to, or 2BP is equal to RS. What's my reason there? Why can I say that 2 times BP is equal to RS? Good, because of midpoint theorem. Good. Midpoint theorem. Right. Good. And we know that RS is therefore going to equal to 120 millimeters, right? But we also know that QP is equal to RS because of what? Why is QP equal to RS? No, not parallel. Not parallel. Yes, I can tell, Pascal, that we're guessing. Yes, that's it, part 2. Because the opposite sides of a parallelogram are equal. Opposite sides of a palm are equal. Good. Therefore, QP is equal to 120 meters. Well done.